Thank you for joining. My name is Erik Rudin. I am the field CTO for cPacket. I'm joined with Nevo, our CTO. And today we're going to talk about a very interesting thing that's coming up more and more with enterprises, which is AI factories are moving into the enterprise. So traditionally, a lot of these workloads have been done in very large data centers that are, have thousands and thousands of GPUs that have run very, very high-speed networks, 400 at the core, 800 potentially. And so as these training models mature, we're seeing the agentic processes push a lot of that workload demand to inference on the edge or into the enterprise. And so this is probably a problem that no one's really yelling out yet, but this is a problem that's coming. This is something that we're seeing. And so Ron's actually going to walk you through a specific use case that really highlights where getting the metrics and the observability connected to inference-based architectures is essential. But it's also important that NVIDIA has been talking about this. They wrote a really great blog about AI factories. If you haven't read it, it's really important. But we know that this is coming. We know that you have to move the agents closer and closer to the customer, closer and closer to the data. And there's a lot of examples for that. And so as these enterprises shift that workload away from the large training workloads to these agentic inference models, these problems are going to become more and more prevalent. So Ron?
Sure. Thanks. Yeah, I think this slide, just to emphasize what we're seeing today in the market. Actually, this section will be a little different than the others. The others, what we try to do is to show kind of what customers are using today and what's coming in the next 6 to 12 months, right? So the things that we're ready to release around MCPs. This one is a little different in the sense that no demos, it's going to be all me talking. And it's more about what we're seeing today happening in the market with our partners, with our leading customers, and what we expect the next set of problems is going to be. So again, if we talked before about AI for network observability, this section is all about network observability for AI, right? And the difference really that I want to focus on is this AI factory. And the big difference is that when you do training, there is a lot of literature already written around it, and it's really huge, very elephant flows, very low entropy that runs for weeks and months in the same way. And they generated a very specific set of problems that people are dealing with them. For the most part, they're being managed by the top 4, top 5 companies in the world with a lot of tools that they already have. As we talk about AI factories, that goes to our ICP, right? Our ideal customer profile, which is much more of an enterprise that has a data center, can do things on its own, has some other considerations that are not just training. And then when you start talking to vendors, partners, academia, there is very little understanding of how inference is going to look like. How is it looking now today, right? Because most of the traffic is still around training, but when you go forward, if you listen to Jensen in the keynotes, it's going to be all about inference. But when you start trying to dig in and say what is inference, there are very few answers, right? How does it going to impact the network? What does it actually going to look like? So what I wanted to do in this session is talk a little bit about what we're seeing and why we think observability is relevant, in the context of observability, why we think we need packets, and if you need packets, why the metrics that we can generate from cPacket are going to be relevant. So a lot of that is just going to be talking about what is inference, right? So if you think about inference at a very high level, you are talking about AI clusters, and we wrote AI inference. They always, there can be some level of training, but in general, let's assume that most of the workflow here is going to be inference. And you're seeing 2 very big categories. One is the interaction with the user or the agent. As you saw, the MCP agents are generating more and more traffic. They're going to have a very different pattern than users. Users work from 8 to 5 for the most part. Agents can do all their work at night. But from a network perspective, it's still going to look like a query and a response. And many of the queries and the responses will become a session. And at the same time, one of the biggest questions that the designers of these clusters have today is what should be their policy of managing the KV cache, right? The KV cache right now is a magic pill of accelerating many things, but if you decide to evacuate it to the external storage, it can cause, too soon, it can cause a big hit on your performance. And one more word, the performance really, if I go back here, is really the challenge, the technical challenge that people have is they want to maximize the GPU utilization, right? GPUs are very expensive, but there is also SLA or SLO for latency. Because I can maximize to 100% by generating a very low latency, right? I can have one GPU, do everything on the GPU will be 100% of the time busy, but everybody is gonna wait, right? So how do I balance this equation is really the technical challenge that people have. So what we've done, again, with our setups and working with partners, is trying and break down, and I don't want to go through all the different levels, but break down the different workflows that we know of today, right? Tomorrow it's going to be a little different, I'm sure, but the ones that we know today between users and agents. And how do they impact, how are they going to look at when I view them from the network perspective? Right, so the U1, U2, U3 are users, A1, A2, A3, 4 are agents, and you can see the ones that, hopefully people are familiar with, right? The prompt response is really the typical one, tell me something about the book. Streaming is a little more efficient in the way that they can receive the answer. And then, media generation, right, when I want to generate an image. And then we started seeing some of these automatic agents, right, some of these agents, right, just in the rest of the demos. And they can generate a very different pattern, right, because the user can, like what I did, ask a relatively short answer, short question. But for it to answer, it had to go to the database, bring up tons of data, send a ton of data up to be analyzed, a short response. So all these ratios are going to be very different when I look at the south-north, the switch that is accessing the cluster, both in distribution as well as in size. And at the same time, the KV cache is also going to be different, right? So the traffic that I'm going to see there going back and forth to storage is going to be different based on the use case. So what you want, well, we'll talk about what we want to do. But this is a statement that says, as you think about inference, and inference being the dominant factor of your network, of your investment in GPUs, in capital, you need to take it into account. And the reason that you want to have an observability is this is the way to improve what you have, right? Without, if you don't have that, you're going to fly blind, right? So you want to make sure that you configure your network correctly. You want to understand how your KV cache. So there are a lot of things that you want to understand based on how, in reality, your network behaves, and in real time. So again, we'll just repeat the picture. So we are talking really about the front end, or it's called north-south. This is the switch that connects the cluster to the rest of the network. Down below, there is what they call east-west or backend, very high-speed networks. For the most part, Rocky or InfiniBand. We're not really dealing with that problem, right? The idea that we are talking about is adding the monitoring points to the north-south. And to repeat the theme that we had before, there is other data that is going to come in, right? There is a lot of GPU telemetry that is coming in. The switches today generate telemetry. The storage is going to change telemetry. So the question is, why do I need also packet information? And these are some of the reasons. And again, I'm not going to go one by one, but being able to monitor the actual latency between the storage and the around the north-south switch will give you a real hop-by-hop latency. Inside the switch, they know how much time the packet spent in the switch, but it's very hard to pinpoint where the latency generated by the cluster was the latency generated by the switch, was the latency generated by the storage, right? So if you really want to understand in which hop the latency was created, you want that. Microbursts. For for different reasons, you can misconfigure your network and create a lot of incast. So if you have the packet drops because of microbursts, it will be hard to identify inside the switch, and the ability to put things together as a session level, right? So again, switches are able to see packets. The GPUs can tell you something about the application, but if you also want to understand the session, this is where packets are relevant.
The nickel many to one, isn't that on the backend network primarily, less so than the front end network?
Yeah.
So that, yeah.
It might be, yeah. There's examples of why we see bursts today.
Okay.
Yep, totally. And nickel is also, well.
Yeah, primarily, yeah.
Sure. So this is the type of information. Now it's interesting. So what I did, the reason I generated this, and if you notice, these are not actually Grafana. These were generated by an LLM, is because Grafana. So even though we have the data, it's actually Grafana is not very good to visualize it. So this is another example where you can play. It's another tool for you to use. So the things that you really want to understand is out of all these 8 use cases, and I'm sure that by the time in the next 18 months, there will be 16 of these, which one is the dominant, right? Which one is sending the most data? How many types you have that? And there are characteristics of these, right? One of the characteristics I pointed out is the histogram or the ratio of ingress to egress, right? So being able to print out the histograms of these sessions based on the ratio of data coming in, data coming out, and size will allow you to say, okay, here's how many I have of each. Given that I know how many I have of each, you can say, okay, this is the right configuration for me to optimize, right? This was the session, and this was the, go ahead.
Do you see augmenting that with the actual query type as well? Because now coming in, even with MCP, you have no idea whether it's an agent or it's a human or the type of query. Do you see like breaking that down as well?
Yeah, I do. Yeah. Some of that will come from the GPU, right? So some of that I will know from how many types of this job had, right? So some of that is in the application. Some of that you want to know, because it can tell you, okay, over the last 24 hours, I had 8 of this and 8 of that, but how did they distribute over time will be a little harder, right? As in over time in a low resolution, right? Where did they all come? Because once the job is landing in the GPU, he may start bringing in data.
Right.
From the storage.
But the GPU tags it, sort of source IP or whatever source port, and then you augment that with the network patterns, then you can see that's the hope, right?
Yeah. We totally see a huge amount of information coming from the telemetry.
Yeah.
Absolutely. And then the other one is just to understand the RTT, right? Again, one of the critical things as you go to inference is the latency, or is the whatever SLA you have for, is it P99 or the time for first token, time for the last token? All this information is critical, right? So basically, see the GPU utilization will come from the cluster, compare it to the latency between tokens, the latency of the sessions themselves. Yeah, so this is essentially just double click about that, right? You want to understand how you classify the flows from the histogram that may impact how you define priority. So these are just examples, right? So you may want to prioritize 0, priority 1, right? The different things that you want to play with them, and probably different specific users will do different things. And then you go to what are the things. So today, there is huge amount of parameters that people just don't know how to use or don't use, and it's just gonna grow, right? If you read the Llama, whatever 70 or very long page, they said, well, we were trying to optimize the ECN. At the end, we said the default is good enough, right? After running a lot of experience, or it's not worse than anything else. So, and without a lot of data, it's very hard to do that, right? So that's essentially the idea.
Great, excellent. Everything you wanted to know about inference networking, right? It's this, like I said, it's coming. I think this is going to become more and more important, and as network leaders, this is something that we need to be thinking about proactively. So when you're thinking about, if you're an enterprise and you're making very large investments in inference at the edge and putting these new GPU workloads into closer to the users, closer to the workloads, we need observability. And we'd like to say we need cPacket analysis doing some of that work as well. So that's really important. And it is a relationship between the GPU, CPU activity with the storage, which is essential. The other thing is that we know there's different types of data. And so this is going to come from, and we've broken that down into agentic or user-based, and I think that's also really important to understand is how do we characterize that data, how do we contextualize that data, and how do we integrate that into the dashboards? And I think this is actually, the evolution of a network engineer. An AI network engineer needs to understand these workflows. And so when the boss says, hey, and we've seen from NVIDIA, the cost per minute can be in the thousands, or in some cases tens of thousands of downtime. So the investment costs are there. Now we need to make sure the observability and the responsiveness of the team is there with matching that same level of investment. So it's continuous tuning, it's optimizing the workflow, it's identifying those baselines, it's looking for the different hop-to-hop characteristics, and it's also integrating it into your daily processes. Okay, so getting to the conclusion, thank you so much for your time today. It's been awesome. Thank you for bearing with our different demos and the slight delay in the morning. But we want to call out 4 key things as takeaways from the session with cPacket today. The first one is that AI is here, but it is not the only solution. It is part of the solution. It is an enhancement, it is an augmentation. It helps the human in the loop. But the best way to sell that is it helps with the outcome. How do we tie that back to the business need? And then do we have the insights coming from the network at the packet level, rolling up to the observability metrics tied to the individual workflow that gives us the ability to solve the problem faster? And that is absolutely foundational moving forward, particularly as networks speed up. All right, and then from our perspective, it's not just a single tool. It's not just a single technology. It's not just having a next generation packet broker or a next generation packet capture or having analytics on top. It's all of it. It's all integrated. It's all open. It's all infused with different things like MCP and LLMs. You need to have this in order to do the speed, the scale to provide that insight. And lastly, let's start with the business problem, right? That's really the core of what we talked about with the customer journey, is how we engage with the customer. We don't start with deep protocol analysis. We start with what are your business challenges and how can we help you move that forward and how can we prove to your boss this is actually going to be meaningful. So if you were to take something out of our session, the key thing to start asking is the what. What is the challenge that you're struggling with? What's driving the business nuts? What are the top networking issues that we can help apply, and what are the metrics that we need to provide to help solve that problem? And then we can engage together and we'll work through the how.